Hello, statistics students. Here's another video on visualizing variability with a scatterplot. Introduction, recognizing trend. The kinds of questions that we're going to be looking at in this section is, at what age do men and women first marry? How does this vary among the 50 states in the United States? These are questions about the relationship between two variables, age at marriage for women and age at marriage for men. The primary tool for examining two variable relationships when both variables are numerical is the scatterplot. In a scatterplot, each point represents one observation. The location of the point depends on the values of the two variables. And again, the scatterplot is used when both variables are numerical. For example, we might expect that states where men marry later would also have women married at a later age. The following figure 4.1 shows a scatterplot of these data, culled from the US Census data. Each point represents a state, and one point represents Washington, D.C. and shows us the typical age at which men and women marry in that state. The 2 points in the low left corner represent Idaho and Utah, where the typical woman first marries at about 23 years of age, and the typical man at about 25. The point in the upper right corner represents Washington, D.C. When examining histograms or other pictures of distributions for a single variable, we look for center, spread, and shape. But when we look at scatter plots, we look for trend, which is like the center, the strength of that trend, which is like the spread, and the shape, which is like, well, the shape. Let's take a closer look at these characteristics. The trend of an association is the general tendency of the scatter plot. As you scan from left to right, usually trends are either increasing, meaning going uphill, or decreasing, which going downhill, but other possibilities exist. Increasing trends are called positive associations or positive trends, and decreasing trends are negative associations or negative trends. Figure 4.2a on the lower left, I should say figure 4.2 shows examples of positive and negative trends. However, the figure 4.2a on the lower left reveals a positive trend between the age of a used car on the horizontal axis and the miles it was driven on the vertical axis. The positive trend matches our common sense, and that is we expect older cars to have been driven further because generally the longer a car is owned, the more miles it has traveled. Figure 4.2b on the lower right shows a negative trend, which is the birth rate of a country against the country's literacy rate. The negative trend suggests that countries with higher literacy rates tend to have a lower rate of childbirth. Sometimes the absence of a trend can be interesting. For example, running a marathon requires considerable training endurance, and we might expect that the speed at which a person runs a marathon would be related to his or her age. But figure 4.3a shows no trend at all between the ages of runners in a marathon. We kind of say those points are all over the place. There is no trend that we can see there. The lack of a trend means that no matter what age group we examine, the runners have about the same times as any other age group. And so we conclude that at least for this group of elite runners, where this data was pulled from, age is not associated with running speed in the marathon. Figure 4.3b shows simulated data reflecting an association between two variables that cannot be easily characterized as positive or negative. For smaller x values, we see the trend is going down, and the larger they're going up. In general, in this particular chapter, we're going to be looking at trends that are linear and trying to determine how strong or how weak they are. And in subsequent videos, we'll discuss how to measure the strength of an association and use this to make predictions. And this concludes this video on visualizing variability with Scatterplot, an introduction, and recognizing trend.